The Sanitary Extruder Hood, or as we prefer to call it, the SEH, is used in the manufacture of small, dry, cereal-based foods produced continuously on a cooker extruder, commonly known as kibble. The new SEH has been designed by Frazer-Nash to meet the latest global hygiene requirements for foods and complies with the FDA guidelines and the European regulation for materials in contact with foods. The need is high for a new sanitary hood design in pet food manufacture. Despite publicity and recalls surrounding contaminated animal food, Salmonella continues to present a genuine threat to both humans and animals. Typically, pet foods are extruded or processed at high temperatures that are sufficient to reduce pathogenic bacteria. However, the possibility for post-extrusion contamination still exists. Frazer-Nash have created the SEH to reduce these risks, using clean air conveying, hygienic design and smart factory layout. Specifically at the post-extrusion stage of kibble production. The kibble process uses the client's cooker extruder to mix, cook and pressurize the kibble recipe so that it can be extruded through a die plate. As the food leaves the die plate, it is cut into small pieces via a rotary knife and carried away on a high-velocity clean airstream. The SEH is bolted to the end of our client's single or twin screw extruder and supports the die in an easily accessible chamber for cleaning and die change. Clean air is delivered under pressure into the cutting chamber and carries the cut food vertically upwards, allowing the soft product to flash excess moisture into the airstream without sticking together or deforming under its own weight. The food is discharged from a cyclone separator into a drying oven to reach final moisture content. The SEH has been designed to work with industrial outputs of 5 to 20 tonnes per hour. The food pieces can be produced in dimensions of between 2 to 35 mm in size and will expand as they leave the die due to steam flash-off from the product. The food can be formed in any two-dimensional shape via the die, and its length is controlled by the speed of the knife drive motor, which operates between 250 and 2,500 RPM. The food is cooked under pressure from 25 to 70 bar, with a 15 to 22% moisture content. Following flash-off after the die and further drying, the final food moisture content will be reduced to around 5%. The SEH is designed to work at extruder pressures of up to 100 bar, which is safely higher than the normal extruder working pressure of around 40 bar. Several times during the working day, our customers need to change the shape and type of food product they are making. Traditionally, this has been achieved by opening the cutter hood to access the die and then removing 20 high tensile bolts that secure the die to the extruder. The new SEH does away with this time-consuming process and the risk of bolt damage impairing the pressure rating of the extruder. Access to the die and cutter is via hinged opening, with a hand or motor-driven bayonet locking ring. No tools are required, and the bolts do not have to be regularly inspected and replaced due to damage. Production room air can contain dust from uncooked ingredients, and if these dust particles touch the cooked food product, there is a risk of salmonella being transferred to the food. The SEH uses a fan to deliver clean, filtered air to the die cutting area at a pressure greater than the production room. Thus, there is no risk of contaminated air entering the pneumatic conveying system and soiling the finished cut product. The SEH is constructed from stainless steel, except for hardened items such as knife blades and die wear plates. It has no plastic or rubber parts exposed to the conveying air to reduce the risk of plastic contamination. The cutter shroud is fully machined for rigidity and dimensional accuracy to maximise cutter bearing longevity and minimise air losses through gaps, as there are no perishable seals present. We have two options for cleaning the SEH: hot air sterilisation and caustic cleaning. For hot air sterilisation, we can use 304 stainless steel construction. This process requires gas or electric heating in the clean air delivery system. For caustic cleaning and chemically aggressive food conditions, we use a 316 stainless construction. Minimal horizontal surfaces with smooth transitions on the internal ductwork minimise food traps and improve draining following cleaning. On start-up and shutdown, product discharged from the extruder is not of the correct quality for consumption and has to be collected in mobile bins positioned under the die. To facilitate this, we have a pneumatically operated sliding valve to allow product to fall under gravity into the bin. To avoid spillage of conveying air and to ensure any good product in the ductwork is kept in motion, there is an air divert valve to allow the conveying air to bypass the die area. Once production is underway, quality control needs to inspect the product being made on a regular basis. We have a pneumatically operated sample port at high level to catch a small sample of post-flash product without disturbing the pneumatic conveying line. To ensure the knife lasts as long as possible between maintenance schedules, Frazer-Nash can supply this pneumatically operated setup tool to preload the cutting disc against each die wear plate. Die stacks can become heavy, and if necessary we can supply this die removal trolley to support the weight of the die stack during die change. Despite our best endeavours, it is always possible for product to block the pneumatic conveying line. To prevent damage to the SEH, we have a blockage detection sensor to shut down the extruder. This design is very flexible and can be adapted to suit a wide range of single and twin screw extruders. We can also adapt the die chamber to accommodate existing customer dies and knives. To complete the switch to our sanitary extruder hood, Frazer-Nash can specify and supply the air handling system, which includes fans, filters, separator and temperature and pressure control devices to ensure it functions at the highest possible hygiene standard.